friends, welcome to my YouTube channel, Our Environment. Today we'll start with our course of the NTA UGC NET. So first of all, I will teach all of you about the environmental pollution and its control. In that, today I will start with the air pollution chapter. Now this chapter I have divided into different sections, or you can say in different lessons, right? So today we'll start with our lesson number 1. In this lesson, we will see what actually air pollution is, what are their sources, then we'll come to the types of air pollutant, then we will discuss about the criteria pollutant and their related health effects, right? So let's start today with our topic, air pollution, okay? So air pollution, as we all know what is air and what is pollution, right? So pollution is any undesirable change in our environment, or you can say in our health, right? Any undesirable change in our environment. Okay. So this is environment, okay? I have written in short. Whereas in you can see air means aerial or related to the atmosphere or related to atmosphere, right? So from here you can understand that air pollution is actually, we are concerning the pollution in the atmosphere, right? So air pollution is actually having two major sources. Now the sources of this air pollution are, one is the natural source, natural, and other one is the anthropogenic, right? So natural source, anthropogenic. Now from here you can understand that natural source actually means anything that is occurring in the environment naturally or without the interference of the human beings, right? Whereas anthropogenic means the causing damage due to the interference of the human beings, or you can say due to the activities of the human beings, right? So natural sources for the air pollution includes the volcanic eruption, then we have the forest fires. All these are the natural phenomena that emits a lot of pollutant into the atmosphere, right? And anthropogenic includes all the man-made activities. It can be the construction activity that releases particulate matters and many harmful substances. Then we have the mining activities. Then we have industrial source as a major source, automobile sources. So all the human generated activities that is leading to the formation of the pollutant into the atmosphere is coming under the anthropogenic sources, right? So I hope it's clear. Now this air pollution, now pollution is actually caused by certain pollutant, right? So pollutant, what are pollutant? Can anyone tell? Just think, what is pollutant? What is the definition of pollutant? Well, pollutant is actually anything which is causing this pollution, any substance that is actually leading to the pollution is termed as the pollutant. Now pollutant are divided into two parts, primary and the secondary. Okay, these are the two types of pollutant, right? So primary pollutant are those which are present in the atmosphere in the same form as they have been released from the source. I repeat, the primary pollutants are those which are present in the atmosphere in the same form as they have been emitted from the source. Like if we take the example of nitrogen dioxide, right? So this nitrogen dioxide, when they are emitted into the atmosphere, was in the form of nitrogen dioxide, and still now they are present in the form of the nitrogen dioxide only, and they have not changed their form into some other compounds. Then we will say this nitrogen dioxide as the primary pollutant. Similarly, you can take the example of carbon monoxide. Now carbon monoxide, you know that carbon monoxide is having the major source as the automobile exhaust. So from automobiles, when carbon monoxide is emitted, either they get transformed into the carbon dioxide or they are present in the form of the carbon monoxide only. So this carbon monoxide, when they are present in the same form into the atmosphere without changing into the carbon dioxide, then we will say that this carbon monoxide is the primary pollutant, right? Similarly, the secondary pollutant are those which are emitted into the atmosphere in one form and they get transformed into the atmosphere due to various photochemical or some other mechanisms, and they are present in the atmosphere in some different form. That is, they are present in different form and they are not actually having the same form as they have been emitted into the atmosphere. Thus, this type of pollutant is termed as the secondary. In this category, you can take the carbon dioxide. Now, carbon monoxide, when it gets transformed into the carbon dioxide, and in atmosphere, when we find this carbon dioxide, then we can say that carbon dioxide is a secondary pollutant. Then another example, you can take the pan. Okay, this pan is formed with the help of the nitrogen dioxide by the help of the photochemical oxidants. Then we will say that this pan is also a secondary pollutant. Then you can take the example of the ozone. Ozone is not also formed naturally, right? It is formed by some photochemical activities or the mechanisms. Then this ozone also becomes a secondary pollutant. I hope it's clear. Okay, so what are the primary pollutant? Now, primary pollutant are those which are emitted and are present into the atmosphere in the same form as they have been emitted from the source. Whereas secondary pollutant are those which are emitted in other form and they are present in some different form into the atmosphere. That is, they have changed their form after the emission, right? They have formed by the different compounds mixtures. Okay, so this type of pollutant are known as the secondary pollutant, right? Now we will come to the criteria pollutant. Okay, I'm rubbing all this. Okay, so now I will talk about the criteria pollutant. So, the Air Pollution Control and Prevention Act of 1981 has given 6 criteria pollutant. Okay, now what are the 6 criteria pollutants? 6, okay. So, this 6 criteria pollutant includes the NOx, or you can say the oxides of nitrogen, right? Then we have the SOx, oxides of sulfur. Then we have PM, or you can say the particulate matter. Okay. Then ozone, carbon monoxide, and the lead. Okay. So, can you tell me among these 6 criteria pollutant, which one or which are actually the primary and which one or which are is the secondary pollutant? Okay, just take your time and identify those. See, first we have the NOx, then we have SOx, particulate matter, ozone, CO, lead. Just think 1 minute. Okay. Just pause and think. Okay, so I'm telling this NOx, oxides of nitrogen, is the primary because they are present in the atmosphere in the same form as they are emitted, right? Similarly, the SOx is also the primary. Particulate matter is also the primary. Ozone cannot be generated from any source directly. They are actually photochemically formed and thus they are secondary. Then we have the carbon monoxide. This is also primary, and finally we have the lead. Lead is also primary, right? So you can understand from here only ozone is the secondary one. Okay, so now one by one I will come to each of this. I will tell some important point related to this all criteria pollutant. Then I will discuss about the concentration and their related health effects, right? So let's start with the NOx. Okay, so I'm rubbing this whole thing. I need space. There are two major forms of NOx that is important for the study of this oxides, because these two forms, they actually degrade the human health. Okay, first is so let's start with the NOx. So the major two forms which actually is of the major concern is the NO and second one is the NO2. These both are potentially harmful. Okay, potentially harmful, right? Now this NO is present in the atmosphere at a very low concentration, and thus you can say that this the related health effect of this NO is quite less because they are not present in a high amount in the atmosphere. Now we have this NO2. Now NO2 is present in a vast quantity, or you can say at a very great quantity. So we need to think about this NO2 mainly. Now this NO2, they reaches to our lungs, right? They reaches to our moisture filled lungs. In them, they absorbs the moisture, they absorbs the moisture and forms HNO3. Now HNO3, you can understand it's an acid, right? So they actually damage the lung tissue. And also it can lead to lung cancer. And thus this NO2 is a potential carcinogen. Now you can understand this carcinogen. Carcinogen are those compounds which have potential for causing the cancer. Okay, so nitrogen dioxide is actually a potential carcinogen, right? Is it clear? Now I will come to the concentration of the nitrogen dioxide. As I have already mentioned that this nitrogen dioxide is of great concern as their concentration is higher into the atmosphere. Thus I will discuss about this nitrogen dioxide health impacts. Okay? Is it clear? Now here you can see the effects of nitrogen dioxide on the human health. Right. So here I have have shown the concentration, which is in ppm. Then I have shown the exposure time, and finally the health effects. Now, before I come to this part, I would like to say one thing. First is, what is acute and what is chronic toxicity. Now, you have to understand the difference of these two before we start this one, because I will say something here regarding it. Okay. So, acute toxicity is something which occurs when we get exposed to a higher concentration of a substance or pollutant, or you can say chemical, for a short period of time. That is, a chemical which is having a higher concentration and thus is require a less time to cause the impact. Like if you take the example of the concentrated H2SO4, right? So when concentrated H2SO4 comes in contact with the human skin, what happens? Immediately it burns our skin. Now this is an example of the acute toxicity, where the exposure time or the time of exposure, what you would say, is small and the concentration is high, and thus the impact created by the chemical to affect you is great at a shorter period of time. Whereas similarly, if you see a chemical is having a short concentration or a small concentration and it is taking a long time to cause the impact, then we will say about that chemical as the chronic toxicity. What happens in certain cases, if we inhale a chemical or we regularly come in contact with a chemical for a short period of time, then for a long period of time, and the concentration of that chemical regularly we intake is small, then after certain years or certain months, what happens? We feel that yes, we are having something toxic effect in our body. So this is what the chronic toxicity is. It will be much more clear if you see here that 0.06 to 0.1. This is a very small amount, right? So this small amount take around 2 to 3 years. If we say suppose example, this small amount is regularly inhaled for 2 to 3 years, right? So after 2 to 3 years, there will be some health effects. So this is an example of the chronic toxicity. So what is the actual effect? Well, it causes increase in the acute respiratory diseases. Okay, so after 2 to 3 years, what will happen? The respiratory disease will develop in the individual. Then when the concentration is up to 0.1 ppm and the exposure time is for the 6 months, then what happens? There is increase in acute bronchitis, and this is for the children, not for the adult. Okay, this one is for the children. Okay, this is for the children, right? Then we have the concentration 0.12. You can see here the concentration is rising, right? Whereas the exposure time is decreasing. Okay, so here you can see it's for less than 24 hours. See, the concentration is 0.12 and the exposure time is less than 24 hours. Then what happens? The human olfactory threshold occurs. Okay. Then we have 5 ppm. Now at 5 ppm, when the exposure time is 10 minutes, then what happens? There is an increase in the airway resistance. Okay, there is increase in the airway resistance. I hope all of you can understand this is the sign for the increase. Okay. Now when the concentration is increased by 90 ppm and the time of exposure is around 30 minutes, then what happens? Finally, the pulmonary edema results. Okay. I think it's clear. You can write it down. You can pause and write. Okay. Now we will start with the SOx or the oxides of the sulfur. Okay. So we'll start with the oxides of sulfur. So this oxides of sulfur is an irritant gas. Okay, it causes irritation. It's an irritant gas. Okay, it causes irritation of the throat, nose, tongue, eyes. Okay. Now, another thing is that when 90% of the sulfur dioxide is inhaled, this affects the upper respiratory tract. It affects the upper respiratory tract. Okay. So when 90% of the sulfur dioxide when inhaled, it affects the upper respiratory tract. Moreover, it also affects our mucous membrane. Okay, it also affects our mucous membrane. Now we will see the related health effects with this sulfur dioxide. Okay, SO2. We'll see mainly the health effects with this SO2. Right. So here you can see the effect of sulfur dioxide on human health is given. So at 0.2 ppm concentration, this is actually the lowest concentration which results into the human response, right? This is the lowest concentration at which we first get the human response. Then we have 0.3 ppm. Now 0.3 ppm is threshold for the taste recognition. As I have stated earlier that sulfur dioxide causes irritation to our tongue also. Thus you can understand here that 0.3 ppm is that concentration at which it causes a threshold for the recognition of the taste. Okay. Then we have 0.5 ppm. Now at 0.5 ppm what happens? It occurs as a threshold for the odor recognition. That is, it affects the nose. Okay. Then at 1.6 it is for the threshold for reversible bronchoconstriction. That means it induces the reversible bronchoconstriction in human, healthy human, right? In healthy human. Now at around 8 to 12 ppm what happens? First throat and eye irritation result. And another thing is that around 20 ppm, immediate coughing starts. Results. Okay, so it's clear. Actually, I have rubbed first three. So if you want to copy, you just pause, go to that time, you just pause it and then copy it down. Okay. Okay. Right. Now we will start with the carbon monoxide. Now carbon monoxide is also very important. Why it is important? Because it is having a straight away relationship with the blood. Okay, with the blood and the oxygen carrying capacity of the blood. Right. So carbon monoxide. Now this carbon monoxide when inhaled, it directly diffuses into the bloodstream. Okay, where it combines with the hemoglobin and replaces the oxygen molecule. Okay, I repeat, this carbon monoxide, it replaces the oxygen molecule present in the hemoglobin, and thus what happens? It binds with the hemoglobin, forming the carboxyhemoglobin. Carboxyhemoglobin. or you can say COHP. Right. Now this carbon monoxide is having 200 times greater affinity towards the hemoglobin than the oxygen, and thus it becomes very easier for this carbon monoxide to replace the oxygen. Now as the blood or the red pigment hemoglobin deprive of the oxygen, and thus all the systems gets hampered, because we all know that blood helps to transport the oxygen to all the tissues, to all the organs, to all the cells of our body, right? So as the blood is deprived of the oxygen, therefore all the organs also starts depriving of it, and thus the person who is suffering out of this causes it occurs the death. And the death occurred by this carboxyhemoglobin, or the lack of the oxygen, you can say rather properly, due to the lack of the oxygen, is known as the asphyxiation. Okay, asphyxiation. Clear? And so this carbon monoxide is of great concern. Okay. Now we will study about the health effects of this carbon monoxide. Okay. The health effects of this carbon monoxide. So now here you can see that carboxyhemoglobin and its level in blood and its related health effects is given here. Right. So it's given in percentage, that is around 1 to 5% presence of this COHB in the blood causes the increase in the blood flow to the certain organs. Now the persons who are having severe cardiovascular diseases, they may lack this blood flow, and thus they can die out of heart attack. Okay. Then around 5 to 9% presence of the COHP level in the blood causes the visual light threshold. Okay, you can see here it causes the threshold for the visual light. Then around 10 to 20% increase of this COHP levels in the blood results into the labored respiration. Now the persons with severe cardiovascular disease may die due to this. Okay, they may fail to compensate, and thus it can be lethal for them. Okay, now presence of 20 to 30% of the COHP causes the headache and sometimes results into nausea. Then at 30 to 40% present in the COHP levels in the blood, there is severe headache, nausea and vomiting is observed. Now when the COHP level in blood is around 40 to 50%, what happens? Slurring of speech occurs. Okay. Now slurring of speech, and sometimes there is a tendency for the collapse of the system. Okay. Around 50 to 60% presence of the COHP, convulsions results, and sometimes it also results to coma. At around 60 to 70%, what happens? There is fatal coma, and for certain person it causes the death. Right? So here I have completed this COHP levels in the blood and its related health effects. If you want, you can pause and you can write it down. Okay. Next we will see the ozone. Right. So now we will see about the ozone. So now we will start with the particulate matter. Okay. So particulate matter of size greater than 10 micron, they gets retained into the nose. Okay. Now particulates which are less than 10 micron, they are termed as RSPM. Okay. So what is RSPM? RSPM stands for respirable suspended particulate matter. Okay. So RSPM stands for the respirable suspended particulate matter. That means those particulates which are having the size or the diameter less than 10 micron, they can travel to the lungs, okay, or the respiratory system, you can say. Okay. Now particulates which are having size between the 5 to 10 micron, the particulates which are having size between the 5 to 10 micron, they deposit on the upper respiratory system. Okay, upper respiratory system. Okay, and those particulates which are having the size or the diameter 0.5 to 5 micron, they gets deposited onto the lower respiratory system. Okay, or you can say in the or in the bronchioles, right? And those particulates which are less than 0.5 micron, okay, they get settled into the alveoli region. Now I hope all of you know that this alveoli is the basic unit of the lungs, where the exchange of gases takes place to the blood, right? Like the oxygen, they gets transferred to the all the systems, and the carbon dioxide, they gets transformed back to the lungs for the release, right? This is how the respiration occurs into the lungs. Okay. So this alveoli when gets affected by the particulate matter, so you can understand that there is a problem of the suffocation, or you can say some serious respiratory diseases results like the asthma. Okay. So I hope you can understand from this that how these particulates affect the lungs. Okay. Now I will discuss about the health effects that results out of this particulate matter. Okay. Well, this particulate matter, they may interfere with the natural cleaning mechanism. Natural cleaning mechanism of the lungs, right? They may affect the bronchioles and thus can also lead to the improper ciliary bead, which may again cause the damage to the natural cleaning system. Okay. Now another important thing is that they may be synergistic. This particulate matter can be synergistic. Now, do you know what is actually synergistic stands for? Well, synergistic is the additive effect. Additive effect. Now, this happens when there is another harmful substance or the gases is present along with the particulate matters. Like sometimes what happens, if particulate matters, they become the carrier of the gases like the oxides of sulfur, oxides of nitrogen, where they combine together to cause some additive effect. Like if only one, like only particulate matter or the gas sulfur dioxide say was present, like they would have a smaller effect as compared when both of them are present, right? So together they add the effect of these two harmful substances, and thus they sometimes produce this synergistic effect. Okay, it's clear. Now another thing is that these particulate matters, they sometimes become intrinsically toxic. Intrinsically toxic. Now what this intrinsically toxic means? Now this intrinsically toxic means that they can be alone can be, they can be toxic. Okay, alone toxic. This happens when the particulates are mainly some harmful metals, like you can say it can be asbestos, okay, asbestos, silica, etc. Okay, so they can be intrinsically toxic sometimes, right? So with this we come to the end of the effects caused by the particulate matter. Okay. Now we will start with the lead. Okay. So we will start with the lead. PB. Or you can say lead. Now all of you know lead is actually a metal, right? So when they are present in particulate form, generally then they affects the system of our body, right? So I will discuss this now in detail. The major sources of these leads are sources: metal processing and recovery. Sorry, 1 minute. Metal processing and recovery, incinerators, etc. Okay. Another important is the acid lead battery. We all know about this acid lead battery, right? So all these are the major sources of the lead. Okay. Now I will explain the effects of this lead in 3 different parts. First I will discuss how this lead actually affect the general adult person. Okay. So it accumulates in the bones. Accumulates in the bones, right? Then what happens? They affects the nervous system. In fact, they causes the malfunctioning of the kidneys. This is for the general adult. Okay. Is it clear? Now in children, rubbing this. So in children they affect the IQ, that is they lower the IQ. Okay. Then what happens? They slow down the growth and also causes the hearing problem. Slow down growth. Number 2, number 1, number 3 affects growth, and number 4, they also causes anemia. Okay, this is for the children. Sometimes they also leads to the cardiovascular diseases, as well as they causes the effect on the immune system and the reproductive and the developmental systems also. Okay, so with this I will start with the ozone. Now ozone is the secondary pollutant, and so I am explaining this ozone at the last. Okay, so ozone is also a very harmful gas when it is present in the troposphere. Right. So when tropospheric ozone we are considering, then we have to understand that this is a very harmful gas. Okay. Now ozone is actually a photochemical oxidant. Ozone is actually a photochemical oxidant. 90% of the photochemical oxidant, 90% of photochemical oxidant is actually ozone. Right. Now another 10% includes the PAN, PPN, PPN and so on. Right. So this ozone, it is very harmful. Not only ozone, actually this photochemical oxidant is very harmful because they sometimes lead to the headache, damage to the red blood cells and so many other diseases. So here we will see that harmful effects that is caused only by this ozone, not by the other photochemical oxidants. Here we will only consider this ozone. Right. So we will see how this ozone affects the human health. Okay. So here you can see the concentration, the time of exposure and the effect of the ozone is shown. So when the concentration is between 0.1, this is 0.1 to 1 and the exposure period is for 1 hour, then what happens? There is an increase in the airway resistance. Okay. Now when the concentration is between 1 to 3 and the exposure time is also increased by 1 hour and it has become now 2 hours. So what happens? The fatigue, lack of coordination, all this results. Even severe cough also results out of this. Okay. Then we have 9 ppm. Now when this concentration is increased severely, then time doesn't matter because concentration is really very high. So at a very low time also they will result into the pulmonary edema. Okay. So I hope you have understood this topic of the air pollution, and this part 1 of the air pollution I hope is clear. Now if there is any doubt, please do know, let me know in the comment section so that I can clear all of your doubts. Okay. So please, if you have any problem with this today's lesson, you want to have some sort out of the questions or you have any queries, please notify me into the comment section. Right. Thank you.